Good morning, Vlad's here. Today I'm gonna do a bit of algebra, the, a very simple algebra. So it's called simplification. A lot of us don't like algebra. A lot of us don't like math, except for those people who created math, right? I don't know, yeah. But there's bits in life that we have to go through. Algebra is one of them. You have to go through it in order for you to go to the higher grade or the higher year. So we have an expression x minus parenthesis x cubed minus x minus 5 close parenthesis. Then you add that with expression 3 parenthesis x squared minus x. Okay, so there's a basic rule in mathematics wherein you don't just, if there are more than one operation there, then you don't just simply go from left to the right. No, the answer would be totally different. They made a contraction PEMDAS, or for others, they say GEMDAS. The difference is basically the P there and the G there. P here stands for parenthesis. G here stands for groupings. So parenthesis is really limited to just this bracket right there. But for grouping, you have more. You can have this, this, and this. That's why GEMDAS is in a uh, uh, broader use than PEMDAS. Okay, so we go back with expression. Um, we check with the parenthesis first. That's the meaning or grouping. E stands for exponents. M, multiplication, division, addition, subtraction. That means that if you see subtraction and then you see exponent, you solve exponents first before you solve the subtraction operation. Here we can see subtraction, we can see addition. What else? We can see exponents, we can see parentheses. Could we see multiplication? Yes, we have here 3 multiplied by what is within the parenthesis. And also here, we have a negative sign, but we don't see the invisible 1. We don't really need to put 1 there because of the identity rule, wherein 1 times anything would result to that same thing. So 1 times x cubed would be x cubed. In here, let's solve for within the grouping, but there is nothing really to solve there because we cannot subtract uh, unlike variables. Unlike variables, meaning the base should be the same and the exponent should be the same. So the base here would be the same x, but the exponent here is 3, while here the exponent is just 1. So you cannot subtract that. You cannot add it as well. In here, it goes the same thing. You have the same base, but you don't have the same exponent. You cannot do anything about that. So that goes away. I mean, the groupings, we cannot do anything with the groupings. We go with the exponent. Variables with exponents, you cannot do much about that anyway. If that is a number, then yeah, you can multiply it depending on the exponent. So let's leave that exponent, nothing there. How about the multiplication? I told you here it has an invisible 1. We don't really need to put it because it is actually useless if you multiply it with other digits. But in in this case, we are trying to multiply the negative, which is very important. We're going to distribute it to that. and here, and there. Also, 3 here will be multiplied with x squared, and we will multiply it with negative x. So the next part here would be copying x, bring down, because there's nothing to do there. Well, here, negative 1 times x cubed, that would be x, negative x cubed. And here, if you are multiplying the same signs, then that would always be positive. So negative times negative is positive, positive times positive is also positive. So in here, it becomes positive x. And here, negative 1 times negative 5, same thing. It is the same sign. So it becomes plus 5. Plus the expression that you have here, you'll be distributing 3 as well. So 3 times x squared will be 3x squared. Well, here 3 times negative x, you have to remember this negative here is part of the x. So 3 times negative x would be minus 3x. Okay, there you go. So what did I say? So there's nothing to divide, sorry. If you have addition and subtraction, then I told you a while ago that it should be the same base and the same exponents. So you bring those variables together, and then you can do operations. The rule, I don't know if it's a rule, but it's normal for you to put the exponent, the highest exponent, to the left, and then it goes lower. The one without variable would be the last. So the biggest exponent here would be cube, the x cube. Then the next